All right, so good morning, welcome. So we're going to talk just a little bit this morning about what is P-Chem, kind of lay out the semester, okay, let you know what's ahead of you, and if you're continuing on to P-Chem 2, what's ahead of you in the second semester, because it's amazing what we're going to cover in just 9 short months. And so let's talk a little bit about P-Chem. Who's seen the Ant-Man and the Wasp? All right, the quantum realm. I love that scene where they're in there and talking, and he says, "Do you guys just put quantum in front of everything?" And I was like, "Yes, we do." So we're going to be talking about waves and particles. We might talk a little bit about dark matter and dark energy, but that's really particle physics and cosmology, and so I really don't have any idea what dark energy and dark matter is. And so, but it's part of it, okay? The interesting thing is that they say is 60% of the universe is comprised of dark matter, and you ask them what that is, and they're like, "We don't know." So it's kind of strange when you see scientists, at the top of the hill saying we know everything, and then you really ask them, what is this dark matter stuff, and they're like, well, we see evidence for it in the gravity of objects in the universe, but we can't probe it with light. And so this course is really dealing with light interacting with matter. So that's the main point of the course, is to talk about how light interacts with matter. And so on your homework this week is to just think about that, okay? You've got one whole page dedicated to just examples that you can come up with in your everyday life of devices that use light, interact with light, reflect light, scatter light, emit light, absorb light. So how does matter interact with light? So just be thinking about that. I want to try to prime your mental pump and get you thinking about devices and things in your everyday life that emit light or interact with light. I mean, just in this room, we've got the lighting. We've got mercury tube lights. You got a mercury vapor in there with electricity going through it. It's ripping electrons off the mercury atoms, and sometimes those electrons end up back on the mercury atoms, and as they drop down, they emit light. And that's what's lighting our room. So we provide a little bit of electricity to a mercury vapor and we get light. The reason we like mercury, even though it's toxic, is it emits red, green, and blue photons. So we get all three that fool our eyes into thinking we have a full spectrum. So there's an example. So not that you would know all of those details before you take the course, but the idea is, hey, we've got tube lights in our room. We put electricity in and light comes out. How does that work? Well, we're going to be thinking about that this semester. So just give examples in your homework this week on light interacting devices. Let's think about the energy scales that we're going to cover from this point through May, if you will. And I realize not everybody's going to continue on to P-Chem 2, but for those that do, when we get to late April, we're going to be talking about energy, and the energy scales that we're dealing with at that point in the semester are global energy scales. We're dealing with exajoules. Now, rarely do we use the prefix exa. That's a metric system prefix, and it's 10 to the 18. We've gotten up to tera, right? You can get a terabyte hard drive. That's what's right here, this little thing on the back that's capturing the video. It's a terabyte hard drive. It fits in my shirt pocket. It's amazing. When I was in college, my first hard drive was a 40 megabyte hard drive, and it was like a, it was, I'm trying to think of what object it would be similar to. It was pretty much the same as a small tower case now. Like the whole PC would fit in my 40 megabyte hard drive back then. Yeah, and a megabyte. It's not even a decent thumb drive now. And so we're dealing with gigabyte thumb drives and terabyte external drives. So exajoules is 10 to the 18 joules, and 425 exajoules is the world consumption of energy per year. So that's a huge number, 10 to the 18 joules. Let's talk about distance scales. If you've got really good vision, you could probably see a dust particle that's about 100 microns across, or 0.1 millimeters. So next time you're looking at a meter stick, the smallest unit of measure is 1,000th of a meter. That's a millimeter. And you can see a dust particle that's probably 1/10 of that. But that's pretty much the limit of your vision. So that's why we enhance our vision with microscopes and so on. But then we get down below into the nanometer range, and who's heard of nanoscience, right? All of this whole business with nanotechnology. Why is nanotechnology an interesting thing? Well, because we're getting close to quantum effects. And so when we get into the hundreds of nanometers range, 0.1 micron, we start to see a mixture of kind of bulk properties and quantum properties. And so there's nothing super mysterious like in Ant-Man, okay, about this. It's just some of these quantum effects we can utilize now to our benefit. And so we get down to nanometers, that's a billionth of a meter. So you take this meter stick and divide it by 1 billion, that's a nanometer. And about 1 billionth of a meter is the diameter of a buckyball, C60. And so you're talking about carbon nanotubes, those are about a billionth of a meter in diameter. And they're making these fibers that are almost a millimeter long. And so we're able to make fibers that have quantum properties. So that's pretty exciting. And then we get down to 1 angstrom, which is 10 to the minus 10. Now this is a definition that you may not be familiar with. You may have seen angstroms in physics, but if you haven't, this is an important unit of measure for us because it's about a bond length. Okay, a hydrogen bond length is about 1 angstrom. And all the other bond lengths are maybe 1.5, 2 angstroms. So angstrom is a unit of measure that we use a lot. So it's 10 to the minus 10 meters. So there's 10 angstroms per nanometer. So we're definitely in the quantum realm there. We're talking about 2 atoms that are held together by the Coulombic attraction of their electron cloud. And we're going to study that kind of bonding this year. So we're going to be knee deep, waist deep, chest deep in the quantum realm. We won't go all the way in, okay, because it's dangerous. So thinking about this quantum realm, light interacting with matter is definitely down in this quantum realm. And then what's the energy? The global consumption of energy is up here at 425 times 10 to the 18 joules. The energy of that hydrogen bond is 10 to the minus 21. It's 32 times 10 to the minus 21 joules. That's a zeptojoule. Okay. So we've got exa down to zepto. It's crazy, isn't it? And so how many, you could do this just for fun, how many hydrogen bonds would you have to break to power the world? Right? You've got an equality down there, 32 times 10 to the minus 21, and then you've got 425 times 10 to the 18. You could add 18 and 21, and that would be your order of magnitude difference. Yeah. So it's quite a lot of hydrogen bonds, and we do that every year, okay, to power the world. So this is a bit of philosophy time. This is one of my favorite quotes by Da Vinci, and he says, "Study without desire spoils the memory, and it retains nothing that it takes in." Now that's a problem, isn't it? Retaining nothing. You study, and it doesn't stick. Okay. And so this is a group discussion. What does this quote mean to you? First person answer in the back. And not the TA. Yes? Have you experienced that? Definitely some nods. Examples of trying to study something you didn't care about.
Probably
English? Yeah, be careful. Don't say P-Chem. Okay, English, yeah. What specifically? Like
grammar.
Oh, yeah, the grammar. Parts of speech, yeah.
Structure.
Yeah, exactly. What else? Another example of studying something you really struggled with. Zoology? So, what was it about zoology that?
I don't personally don't care about all the filing cubes and classes.
Oh, just memorizing all of those different, the classifications. We don't have a lot of those classifications in here, so we're probably pretty good. Yeah, that's good. Yeah, so this list of words, that was always my toughest. You know, in high school Spanish, I would just, how do you learn a vocabulary? Flashcards are a good idea. I didn't do flashcards. I just wrote the same list over and over again, the same order. So I kind of have a photographic memory. It's not perfect, but it's pretty good. And so if I just copy the same list over and over again, and this works for vocabulary, it probably won't work for this course. But I'm listing all of my verbs, and I've got the definitions, and I'm on the final. And I know Salir. I'm like, oh, I know this. but I just can't retrieve it. So I close my eyes and I'm thinking and I'm reading my vocabulary list. And I can see Salir, but I can't see the definition. And so I'm sitting there and Senor Gonzalez says, Mr. Williams, are you crying? And I said, no. and I said, no, I'm reading my vocabulary list. And he said, show me your hands. And I was like, what? And he said, oh, I thought you were cheating, you know. And I said, no, I'm thinking about it. And she was like, to leave. I was like, I got it. So he said, it worked? And I said, yeah, it worked. You know, but that was difficult. I mean, I wanted to speak Spanish, but learning the vocabulary, you know, that was a difficult thing. So my point with this is many of you are desiring a degree, you're desiring a job, you're desiring a good grade. But none of those three things, although they're good desires, are going to help you study and retain. You've got to desire the content. So however you can get your interest plugged in to the content, that's key for you to remember any of it. So any particular subtopic that we're dealing with in P-Chem, you've got to figure out something about it that interests you. That's like the save button, that little spark of interest. And so if you can generate that, I'm going to do my best in class to try to help you understand the interesting parts of it, but you've got to bring something too. You've got to figure out what it is that's interesting, neat, unexpected, and that will help it stick. Okay. So let's do a Kahoot. This is another thing that we're going to do in this course. And so what the Kahoots are is it's a little online quiz. Okay. Let's see if this works with the pen. And so you'll need some sort of device that connects to the internet. It doesn't have to be a smartphone. If you have an iPod Touch or can borrow someone's Kindle Fire or whatever, something that can connect to the internet so that you can click your answer buttons. There is a Kahoot app. You don't have to have it. You just go to kahoot.it. So that's the web address if you're using a browser. Kahoot, K-A-H-O-O-T. This is slow to load, so I'll write it down. And it'll ask you to enter in the game code. The game code will come up here in a second, and then it will ask you for a nickname. Now, you may have done this in the past in other courses in high school as well, but for this one, so I can keep track of the roster, see, this kind of replaces you signing a roster, which was always a pain, everybody crowding up here trying to get to the signing the roster. Use your email, like your initials and numbers. So ABC123, you know, whatever your initial number code is for your email, your SAM email, that way I can line it up with the roster that I have in Excel. So this is just a short survey. And if you've got something to write on, because some of these you're not really going to have an answer up here, it's a prompt. So I want you to write for 2 minutes in your notebook, okay? So go ahead and get your pencil out or your pen and your notebook paper ready. Okay, so this is the game code for this course. Let me get that. So it's 9655367. Yeah, perfect. That's what I'm looking for. If you're not registered for the course yet because of whatever paperwork, go ahead and play along, and that'll show me that I've got some folks that aren't on the official roster. Very good. So I had 54 on my roster this morning. Is anyone else trying to get in? Okay. Now, if you have absolutely no access to a device that can connect to this, come to me after class. We'll figure out a way. Sometimes I have people do it on note cards. If you forget your phone or don't have any device that day, you can write it on note cards. So you can bring some note cards. Okay. So what is your major? So in red we have the chemistry ACS degree. Blue is forensic chemistry. The yellow or orange is chemistry, other tech careers, and then some people sometimes are here from other majors. We've had physics majors in the past take the course. This just gives me a kind of a nice bar chart to see what we have. Okay, so looks like we're about 2-to-1 forensic chemistry and a couple of others. Fantastic. Okay. How many times have you attempted this course? This is anonymous for ready, so 0 times, 1 time, 2 times, 3 or more times. And this includes other institutions. Occasionally we have folks that come over from other schools. I had one person come from UT who thought it was going to be easier, and they quit the second week. So, yeah, I was proud of that. All right. So why are you here? This is a 2-minute write, so take your time. Why chemistry? What are you striving for? What's your hunger? So this is kind of feeding into your interest in the topic. It's a 2-minute write, so just top of your head, getting your mind thinking about why are you really here? And specifically, why chemistry? I mean, okay, time's up. It's okay if you're not finished. The next one is a really deep thinking question. You've been students for a while, okay? What keeps you from success? What gets in your way? What holds you back year after year? This is you writing to you. You don't have to tell me, you're not going to turn this in. But I want you to think about in the past when you've blown a test, and who hasn't, what kept you from success? Is it a favorite TV show? Too many friends? Not enough friends? Okay, now the next question. What are you going to do about it? It's time to make a plan. Be specific. So if there really is something that you can identify that does hold you back, how are you going to change it? Some things we can change, some things we can't. But how are you going to manage it if you can't? Come up with a plan today. Okay, time's up. Thank you for playing. All right, let me save the results. Okay, so P-Chem's not a new course. You guys have heard about it. How many people have heard scary things? Okay, let the record show there were a lot of hands. Okay, so I would say beware the P-Chem storytellers. Okay, they talk. Most of the time, you hear about people who really struggled, and the thing is, if you're going to talk to somebody about how hard a hike was or how hard a task was, most of the time you're gonna make it sound worse than it really was, right? Because you want everybody to know how bad it was. Okay. Now a lot of times too, it's bad because of some of the things we just wrote about, poor time management and so on. But it can also be bad if you don't reach out for help. And I think that's the one we can work with. If you do find yourself struggling, you miss a particular concept, ask others and ask me. I'm not understanding what you mean by this. There's a lot of terms that are brand new, terms you've never even thought about. Transition dipole moments and irreducible representations. These are words that don't mean anything at all to you. Okay, and so if you don't get those down very clearly, then I'm going to continue using those terms, and you're not going to have any idea what I'm talking about. Okay. Now, one thing about beware the P-Chem storytellers, and that is they just talk up a tough story about how impossible the topic is, but it's not impossible. Okay. Now, one thing though I've made a significant change this semester. A few significant changes, but the number one significant change is I've reduced the stakes, the high stakes exams. In other words, having 4 exams, there was a lot riding on each exam. and a lot of material in each exam. And so I've taken the material and chopped it up even more, and now there's 8. So there'll be lots of checks on your understanding. So about every 5 or 6 lectures, so that's every 2 weeks or so, we're going to have an exam that's going to check your learning on that. And that's going to be probably the most significant change, because it's going to keep you in the material, and it's also going to help you check yourself at a lot of checkpoints along the way to find out how you're learning. Yes.
I saw in the email you sent out in this syllabus. Are we needing scantrons, or are these written?
Yeah, scantrons and written. So you'll have the green long form that has about 50 questions on it. I won't use all 50, but that's just the scantron I'm used to using. So let's just use that 50 question. It's E882E, I think. And I'll probably have about 20 questions on the exam, and then 1 or 2 worked problems. Because I want to see you actually use your pencil and explain to me how you understand the material. But I don't like having an exam with only 4 problems on it. You know, I like to also check a lot of the vocabulary and things like that. So I have a lot of multiple choice questions that you should be very quick with, and then 1 or 2 worked out problems so that I can see how you think. Okay, and see, I can tell right away if that's the first time you've done that problem, because it's, you know, all over the place and lots of erasures and mark-throughs, or if you've done that problem and you're confident with it, your work is organized and clear, and you can state your assumptions and so on. So it just tells me, you know, how confident you are in your work when I see a nice written out problem. The problems are going to be very similar to the things that are assigned in the homework, and so there shouldn't be any surprises. A lot of times too, I'll tell you, because there's a fair amount of material, kind of what to focus on for that written problem. So it won't be, I won't tell you exactly what it's going to be asking, but like a transition equation, if I have you in class or in your homework, work out a transition equation for a change of 2 quantum states, I might ask you on the exam a change of 3. And so I say, you tell me, write out a transition equation for delta n equals 3. And it's slightly different than what you did on the homework, but I can still see if you're confident in doing that. So that's a big change, and that will be in your benefit. And it's a response to some of the feedback on student questionnaires. The other thing that I'm changing is I'm keeping the 10 pages a week of homework, but I'm going to provide you more guidance. So I'm going to say you need to define these 15 words, okay? And you need to work these 4 problems. You know, I'm going to give you specific problems. So this should take you about, you know, 3 pages of vocabulary, 2 pages of work problems, and then a couple of extra that are just your own study, trying to work out things that you don't understand in the text or in the notes, okay? The point of those is for you to do about 2 pages a day. So just staying in the material every day makes it so much easier to learn. And the cramming is the worst way to learn. It's great for my Spanish vocabulary, right? The night before the test, write that thing out 5 times, because there's no thinking involved. But when you have to think about something, you have to understand it. And that comes from taking tiny little bites every day. Okay. So we work with this idea of being able to do the material, and we really have this this difference between I can do it or I can't do it, and we worry at this point about being able to do something. So I know right now you're kind of between this, can I or can't I do this material, okay? But the next thing that we need to focus on too is will we or won't we? Right? And so there's different intersections of these two. So this intersection is I can and I will do it, okay? But we might have some situations where I can't, but I want to, right? And so that's not red, that's just blue. That's this sort of, you know, we really want to move you to the green, all right? And then I can, but I make poor decisions. So I've hampered myself in some way. I can do this, but I won't because I've screwed things up. I've committed to too many organizations, or I've said yes to this and that, or I've got my favorite TV show that I have to watch. In fact, 3 of them. Okay, and so that's poor decisions that are going to take you from I will to I won't. Okay, and then I can't and won't try. Now, there's very many reasons why people give up. Okay, they think they can't, and so then they give up. And so this is a dangerous box to be in. But my point is, I want to move everybody in that bottom row, at least to the top row. Okay, let's get out of the won't and into the will. Okay, and then let's work on getting the can'ts over to the can'ts. Okay, so that's my point. My purpose in life is to take everybody in this course and get them out of that bottom row and into the top row, and then sweep the can'ts over to the can'ts. Okay. So be focusing on this all the time. Try to think, okay, is this a can't thing or a won't thing? And try to get it out of the won't and into the can and can't. Okay. And ask for help so that you can make that move over to the green. Okay, the syllabus, let me focus on that a little bit. I'm going to leave most of it for you to read and study. We'll have a Kahoot quiz on it on Friday. I want this specific book. I know that's going to cause some people some heartburn, but this is the book we want. The reason I like this book, now I've done a full evaluation of it this past year, is it's actually written the way a P-Chem book is actually used. Okay, a book like P-Chem or Inorganic Chemistry or March's Organic Chemistry, they're not written like a novel, right? With chapter 1, and then you got to read chapter 1 or you're not going to understand chapter 2 and so on. That's a linear way of writing. These books are reference books. So you may want to jump in on page 403 and study molecular symmetry. Okay? You should be able to jump in to the middle of the book and understand it if it's a reference book. And this book has really done a good job of breaking the book into topics and focus areas. And so there's a focus area and then a topic. So right now we're going to be in topic 7, quantum mechanics. And so we should be able to drop right into topic 7 and start talking about quantum mechanics and not worry that that's deep in the book. So don't freak out that we're starting on page 200 something, because it's not a linear book. Okay, it's written in topics. It's as if you have 24 separate books all bound into one. And they've done their best. They've redefined the terms multiple times throughout the book so that you don't have to go find it in chapter 1. It's redefined in topic 7 so that you can see some of those definitions. Now, if you do get confused by a word, and most of the vocabulary words are in bold, go to the index, okay, and find all the places where that word shows up, and that's when you get your note card out, and that's when you get your homework pages out, and you write those definitions and you learn the terms. Just like a foreign language, if you don't know the terms, you can't really understand what's going on when we talk about the topic. So this book is required. I'm going to provide, I'm going to point out the sections that we're in and the things that you can read to help you along. I talked about providing clearer guidance for the homework. The CAM Scanner app. Are there any questions about how to do the homework? I kind of gave an outline in that last email. Just get the app, you scan your work in. It's real simple to use. I even showed a video. You just hold it, punch the green camera button. I really do want everybody, though, to put everything into one PDF document. Okay, so if I get like 7 uploaded documents into the homework assignment, I'm not going to grade it because I want you to follow directions. Okay, so. The lab. Let's talk about that a little bit. Our lab meeting place will be in room 102. Okay, so we are going to start there. Typically, even if we go up and collect data from someplace, we'll start there, talk about what we're going to do. Most of this course is data analysis, right? In freshman chemistry, organic chemistry, biochem, you're in the lab mixing things, okay? And you're doing some data analysis, but this is a data analysis heavy experience. So I'm really teaching you how to crunch numbers. That's why I started this Excel bootcamp. So if you haven't watched any of the Excel bootcamp videos, go ahead and get started on that. Tried to keep them short because I wanted everything to be topical. And so they're between 2 and 6 minutes, although the one on charting was 13 minutes or so. But Ashley's been working with me all summer, and I've been saying, how does this work and so on. So she's been looking at the videos already, and she said that the 13-minute one's still okay, that it walks you along. Just when you think, okay, I've got a question about this, then she said, I covered it right next. So yeah, okay. So that's good. I've also given breaking the exams really helps. We went down from 70% of the grade being on exams to 64. I wanted every exam to just be a straight up 8%. Okay, so every exam is 8% of your weighted average. The lab is 20% of your weighted average. The thing that you might be thinking, oh, it's only 20%, but yet it's a ton of work. Well, it's also necessary for you to do well on the exams, right? Because the concepts taught in the lab are really important for your understanding of the material. Out of class participation, that's the homework. So that's 10% of your grade. In class participation, that's taking the Kahoots, using your login ID to get the Kahoots. That allows me to know that you're here and you're participating. That's 6% of your grade. Okay. So if you're skipping out because the lectures are online, you're going to be dropping 6%, almost a whole exam grade, just by not coming to class. Okay, so bad idea. That would be a won't. Okay. So study the details. We'll quiz you on it on Friday. This first homework assignment is really kind of extra credit. I mean, you're going to have about 120, 130 pages of homework, and they're 1 point apiece. So there's a person that's traveling. I think they're still at the ACS meeting, and they're panicked because I've already got a homework assignment. And I was like, dude, it's 3 points out of 120. So it'll be all right, okay? But don't start taking that attitude and just skipping things. But do what you can to get all 10 pages a week. If you only have 7 that week, upload 7. You got 7 points, right? If you're insane and you did 12 or 20, just upload 10 that week and do the 10 for the next week, okay? Now, you can't go backwards in time, though. Like if you miss 2 weeks and then you do 30 pages, I'm not going to give you the 10 points that you missed, because what's my point in the whole homework thing is not cramming, right? And so that would be exactly the opposite of what I want to do, is to let you do 30 pages right before the exam and get credit for 3 weeks worth of work. That's crazy. Plus, you're probably going to resort to just copying down your friend's notebook. That's not going to do any good either. So here's the procedure. I just sent this out on email, but it's now in the PowerPoint if you needed it. And then there's a figure here that's going to panic some people who don't have the book yet. So it talks about figure 7A.8 on page 242. And I'm sure, if you read that in email and you're like, oh my gosh, I don't have the book yet. It's on its way. Come on, Amazon. Here's the figure. So this is an energy level diagram. And so I want you to draw that or make up your own, but something like that in your notebook. And I want you to be thinking about what it means. What it says energy on this scale here, and what do these lines represent? What's going on with these waves? Okay. What are the arrows? Some of these arrows, all 3 are going down, but what would an up arrow be? So I want you already thinking about this, even if you don't quite know. That's great if you don't know. You're thinking about it. You're trying to figure it out. Okay. And then lecture will actually be worth something. We're going to talk about these things and answer your questions. The best way to learn is to get ahead of me, just a little bit. Like 1 or 2 lectures ahead of me. That's the best way to learn. Why? You tell me why that's the best. Yes?
You can ask questions about the lecture that you already know.
Yes. It's better to come to lecture slightly confused about the material. And then lecture actually answers your questions and you come away with this feeling of, wow, now I get it. Okay. If you haven't looked at the material before you come to class, lecture's confusing. And then you go try to study and you can't remember what I said, and so studying is confusing. You flip that. study ahead a little bit and confuse yourself, but on the material, write your questions out if you can. And then when you come to class, then you'll actually be able to get those questions answered. And mentally, it's amazing. You'll be saying, wow, I remember doing this in my junior or senior year in undergrad when I actually started kind of reading ahead before I got to class. Class was incredible. I came out of there like, wow, now I get it, as opposed to the other way where I come out of class like, he is speaking gibberish. And then trying to cram it in at the end, and I was like, I wish I could remember what he said 3 weeks ago. And we didn't have YouTube or anything like that. So anyway, that's the best way to go about it. Here's where you can find me. Stuff is on the board. Also, I've been putting some articles and things and links to the videos on the pchemforall.com. That's my blog. These are my online names, P-Chem for All. But the Kahoot name, if you're searching for all my Kahoots, this one's one you want to write down. Chem_prof. That's my Kahoot ID. And if you will go there, you can see all of my in-class quizzes that we're going to take the whole semester. Now I'm going to tweak them some just because before class I'll think I really want to ask this question, so I'll go in and I'll edit it and so on. But that's really great for when you're studying. So the night before the test, you can go back the last 5 lectures and take all the in-class quizzes just to check yourself. If you make a Kahoot account, you can make your own quizzes and challenge your friends. It's what the great people do. But I actually had a few people do that. They would have a study session. They'd make up a couple of Kahoots and try to trick each other, and it was a lot of fun. They tell me, yeah. So it's great. Is there anything that I've left out that you came with a question and I haven't answered?
Would it be more helpful to have the book in class with us?
No, I don't think so. Yeah, I don't think it'll be that helpful because there's so much. It's so heavy. They're just not carried around all the time. But I will try to find sections in that book to read. Now, with any reference book, and let me tell you a bit about publishing, just 1 minute. They have to include an incredible amount of detail because somebody may have that question. That doesn't mean that we're going to go into that much depth. Okay? So we're going to cover things at this much depth, but the book contains that much depth. And so you're going to be confused when you read that book. Okay? Every P-Chem book is confusing. But pick up organic. Go back and look at it. It's confusing as well, right? So it's not just P-Chem. It's just science, right? And you're not going to get a book through the publisher without that level of detail. So they're not going to write sort of this friendly P-Chem book, okay? They're going to write a reference book. Now, I'm writing the friendly P-Chem book, and I'll tell you more about that next time. I'm going to write the book that kind of outlines how I teach the course, and I teach it mostly in 1 dimension because 3 dimensions are crazy hard. Okay, when you're doing calculus and you're doing triple integrals, 1 integral in 1 dimension is difficult enough. But trying to integrate over x, y, and z, or if it's a hydrogen atom, r, which is the distance from the nucleus, and theta, which is like longitude, and phi, which is latitude, you got to do integrals over all 3 of those dimensions. Let's focus on 1 first and understand that. And so that's really how I teach the course. And then by analogy and using symmetry, we can understand 3 dimensions. Okay, so this course is going to be taught essentially in 1 dimension. And then we're going to do symmetry to get us to the 3 dimensions. So that means you have to think about molecules in 3-dimensional space. So start looking around town, your apartment, your automobile for things that are symmetric. Okay, and recognize the symmetry. Okay, the desk you're sitting in has a mirror plane right down the middle. The left is like the right. Okay. The wheels on your car have rotational symmetry. If they didn't, they wouldn't be very good wheels. Okay? And so we need to start thinking about 3-dimensional objects and their symmetries because that's huge in this course. And don't be intimidated by it, but it's something that you need to start thinking about. Okay. Well, that's great. I'll see you next time.